Hi, this is Walter Stone, and we are going to be looking at Unit 9, Lesson 3, Quadratic Functions. And quadratic functions are of the form ax squared plus bx plus c. So I'm going to use my Desmos online calculator, and I'm going to type in ax squared plus bx plus c, and I'm going to add sliders for these values. And what if I let b equals 0 and c equals 0? This is the basic quadratic function x squared. So if a is 1, b is 0, and c is 0, we'll just have x squared. And we get a basic parabola. And if I change c to -1, we see that because the number 1 is positive, we see that the graph faces upward, and we also have x-intercepts. So -1 is an x-intercept, and 1, 0 is an x-intercept. And we have 0, -1 as a y-intercept. And if a is a positive number, the parabola faces upward. And if I change a to -1, notice that the parabola then faces downward. So if a is a positive number, it faces upward. If it's negative, it faces downward. Okay, so we'll be working with that idea. Now, if a is positive, we have a lowest point, and that point is called the vertex. And if a is negative, then the highest point is the vertex. So one thing we're going to do in this lesson is we're going to locate x-intercepts of a graph, the y-intercept of a graph, and the vertex of a graph. So suppose I want to work with x squared minus 4x minus 5. Suppose I change b to -4 and c to -5. Okay? Now, one thing to observe is that -1 and 5 give us the values of the x-intercepts. So when at -1, 0, when f of x equals 0, we get an x-intercept. So -1, 0 is an x-intercept. 5, 0 is an x-intercept. If we find f at 0, that gives us the y-intercept. So the y-intercept is -5. And the lowest point on the graph is 2, -9, and that will be the vertex of the graph. So we'll be looking at locating the x-intercepts, the y-intercept, and the vertex whenever possible. So one thing to observe about the vertex is that we see that if I take the midpoint between -1 and 5, if I add -1 and 5 together, I get 4. 4 divided by 2 is 2. So taking the midpoint of the x values of the x-intercepts is a way that gives us the x-coordinate of the vertex. Okay, so we'll look at that process of what it means to find that vertex value. And also, if we then take f at 2, if I evaluate the function at 2, the value of the function is -9. Okay, so we're going to be using that idea as we look at quadratic functions and we figure out intercepts and vertices. Okay? Okay, so we are in Unit 9, Lesson 3, Quadratic Functions. And we just previewed the quadratic function x squared minus 4x minus 5. It's of the form ax squared plus bx plus c. A in this case is 1, b in this case is negative 4, and c is negative 5. And what we observed from the graph of that function is that when f of x, where f of x was equal to 0, we found that negative 1, 0, and 5, 0 were x-intercepts. And when we let x equal 0, we found that we should have a y-intercept of negative 5 here. Okay, so we have a y-intercept of negative 5. We also saw that 2, negative 9 was the vertex, and we made the remark that the x-coordinate comes from the midpoint between the x-intercepts. So we figured out that when we took negative 1 plus 5 over 2, we got x equal to 2 as the midpoint of those x-intercepts, and then we can evaluate the function at 2 to get negative 9, and the vertex would be 2, negative 9. So algebraically, what happens is that the x-intercepts come when f of x equals 0. We can then set x squared minus 4x minus 5 equal to 0. We're trying to find the x-intercepts of this specific function. We can factor and then set each factor equal to 0, and we see that x equals 5 or x equals negative 1. So one of the main reasons we learned why to solve these equations is so that we can find x-intercepts of a quadratic function. So algebraically, we would solve this equation for x and get negative 1, 0, and 5, 0 as our x-intercepts. To find the y-intercept, we let x equal 0, and we take f at 0, and we have 0 squared minus 4 times 0 minus 5 gives us negative 5. So we were able to find, algebraically, we can find the x-intercepts, the y-intercept, and the vertex. So if we go to the next page, so here on the next page we want to say that if I have a function in its general form, this quadratic function ax squared plus bx plus c, the x-intercepts come from letting f of x equal 0. So if ax squared plus bx plus c equals 0, by the quadratic formula, we found that taking the opposite of b plus or minus the square root of b squared minus 4ac all over 2a give us the solutions to this equation, and we now get the x-intercepts of the quadratic function. And the y-intercept is found by letting x be 0, and a times 0 squared plus b times 0 plus c gives us c. So 0c is the y-intercept of the function. So the vertex is the midpoint between the x-intercepts. So if I let x sub 1 be the x-intercept that comes from taking the opposite of b minus the square root of b squared minus 4ac over 2a, and if I let the second x-intercept come from negative b plus the square root of b squared minus 4ac all over 2a, if I find the midpoint between those, that means taking half the value of the sum of these two values. So if I add negative b minus square root of b squared minus 4ac over 2a plus negative b plus the square root of b squared minus 4ac all over 2a, what happens is the minus radical plus the radical, that gives me 0. And negative b plus negative b is negative 2b. So I have negative 2b over 2a. And if I take half of that, these 2's will cancel and I'll get negative b over 2a. So it turns out that the coordinates of the vertex of any quadratic function is going to be the opposite of b over 2a. We evaluate that in the original function. So if we take x to be negative b over 2a, that will give us the value of the y-coordinate of the vertex. So we're going to use these ideas as we graph some quadratic functions. Okay, so I'm going to film a second video that shows us some examples of using this theory that we found. Okay, so I will see you soon.